I hope I find you well. It's Jonathan here. Uh, Let us have a look at a couple of questions regarding the differentiation and applications in word problems of derivatives. Okay. So, of course, these questions are from your past papers, past exams, past tests. So, they are quite handy in preparation of your upcoming tests. Okay, let's have a look at this question, the first one. Use implicit differentiation to find the slope of the tangent line to the curve xy squared plus x squared equal to root of x plus 3y at the point xy equal to 1, 1. 4 marks for that. Part B is saying hence find an equation of the normal line to the curve in part A at the point 1, 1. So if we have a curve, okay, so if we have a curve like this, so the tangent drawn to the curve will just touch slightly to the curve. I'm sure we all know this. So at this point of contact, the gradient of the line will be equal to the derivative of the curve evaluated at the point in question. All right. So if I calculate y prime and then evaluate or calculate its specific value for the given coordinates, then that gradient, that y prime, which is just dy dx, at that point will be equivalent to the gradient of the tangent line. Okay, so for us to find the slope of the tangent line, we just have to find y prime evaluated at the point in question, which is 0.11. So let's do that. To find y prime, we do implicit differentiation. So let me rewrite the problem as it is. It's xy squared plus x squared equal to, let me use brackets, x plus 3y to the power of half. Okay, because I want to use the power rule of differentiation, so I want to clearly see what's going on. So that's why I didn't write in terms of that square root sign. So as you can see, xy squared is a product of two functions, f and g, and the derivative of a product, remember guys, the derivative of a product fg is none other than g f prime plus fg prime. Okay, so now let's do the differentiation. So this should be y squared times f prime, which is x. If you differentiate x, you get 1, plus we say x times the derivative of y squared is 2y y prime. Okay, every time you differentiate a y, this is a function of x, so you plug dy dx or just y prime. Okay, then moving on to differentiating x squared, you get 2x as usual. Now on the right hand side, we use the power rule, but this is a composition function. All right, it's a power, and how inside the brackets we have a function there, and it's a function of two variables. So what we do is you differentiate the inside function. So if you differentiate the inside function, you have 1 plus 3 y prime. Every time you differentiate y, you plug y prime, and then after differentiating the inside function, you bring down the power, and then everything comes back, x plus 3y to the power of half minus 1, which becomes minus half. Okay, so this is basically the derivative. Of course, we have not yet simplified it. There's no need for us to simplify it nicely. Immediately we can just substitute the given point so that we get a simplified form of this expression. So we are going to substitute 1 for x and 1 for y. So this y squared becomes 1 squared, which is 1 times 1, so I'll get 1 there, plus, so this should be 1 times 1, plus the first one will be 1 into 2 times 1 y prime, okay, plus 2 by 1 equal to, in brackets we have 1 plus 3y prime. We don't know y prime, so we leave y prime as it is. We are only substituting for x and y. So half comes back, and then 1 plus 3 by 1, which is just a 3 to the power of negative half. Okay, so simplifying this further, you end up with 1 plus, this is 2y prime, right? This becomes 2y prime plus a 2 equal to, so let's simplify here. 1 plus 3 is a 4. So if you say 4 to the power of minus half, it's just the same as 1 over 4 to the power of half, which is just the same as 1 over square root of 4, which is 1 over 2. Okay, so this whole thing will give me half. That half times this half, I'll get 1/4. So I have 1/4, 1 plus 3y prime. Perfect. Simplifying further, we just have to cross multiply everywhere by 4. In fact, this 1 plus 2 becomes a 3. So I'll have a 4 multiplying 3 plus 2y prime equal to 1 plus 3y prime. So removing brackets, you have 12 plus 8y prime equal to 1 plus 3y prime. Moving this y prime this side, then we will end up with 8 minus 3, which is 5y prime equal to 1 minus 12 becomes negative 11, and therefore y prime is equal to minus 11 over 5. And so the slope of the tangent line is minus 11 over 5. Okay, we now know the slope of this tangent. Now coming to question B, hence find an equation of the normal line to the curve in part A at the point 1, 1. So we know that the tangent line has a gradient m1, and the gradient of the normal line is, let's say, m2. We know that m1 times m2, the answer should be negative 1. Okay, so we know m1. So therefore, this then implies that if you want, you can just have mn here and mt if you want, but just only the same thing, just different terms. So m of the tangent, we know it. M of the tangent is this one, minus 11 over 5. M of the normal, gradient of the normal, we don't know it, but the answer should be negative 1. So therefore, m gradient of the normal rather should be equal to minus 5 over 11. We invert times negative 1. So gradient of the normal line is equal to 5 over 11. Now, having found the gradient of the normal line, we can use then this equation which says, so this is part B. So from y minus y1 equal to m into x minus x1, where x1, y1 is the given point, we can just say y minus y1 is 1. Okay, so x1, y1 is known to be equal to 1, 1 according to the question. So replacing y1 and x1, we end up with m is 5 over 11 into x minus 1. So removing brackets here, you end up with y equal to 5 over 11x minus 5 over 11 plus 1. So y equal to 5 over 11x. Yeah, this is 11 over 11. 11 minus 5 is plus 6 over 11. Is the equation of the tangent line. Of the normal line, sorry. Of the normal line. Okay. Alright. So let's move on to the second question. Now this is a word problem in which you are supposed to implement differentiation to rates of change. Okay, this is classified under rates of change. So the basic principle that works to solve these equations or these problems is differentiation. So let's read. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the radius is 25 centimeters? Hint, the volume of a sphere of radius r is given by v equal to 4/3 pi r cubed. In some situations, you may not be given the formula because we know that you must have that basic knowledge. If you are talking about a sphere, it's a perfect circular shape, but solid shape. So the volume of a sphere is known to be of that formula, and you did that in your high school. But in this case, we gave you the hint, so then you have a starting point. So the question is, how fast is the radius? We are concerned about the rate of change of the radius. So first of all, let's derive an equation of the rate of change of the volume with time. So from v equal to 4/3 pi r cubed, let's do the implicit differentiation with respect to time. So we have dv dt equal to 4/3 pi is a constant. So but we differentiate r cubed. So this will be 3r squared. But because we are differentiating a function that is depending on time, we plug the r over dt. Okay, so these 3 will cancel that, and you remain with 4 pi r squared dr dt, which implies that if we make the r dt the subject, because that's the one we are asked to find, they say find the r dt. Okay, so the r dt is equal to dv over dt, the term that is on the left, divided by 4 pi r squared. So let's substitute everything that we have. dv dt is 100 cubic centimeters per second all over 4 pi r. We are being asked at the instant when r is 25, so that's 25 by 25. This is the same as 25 squared. Okay, so I'm doing this so that we can cancel out stuff. So but here we will have centimeters squared because this is r squared. 4 pi doesn't have units, so 4 into 100, that's 25. 25 into one of these cancel, so the overall answer remains is 1 over 25 pi. Then 2 of these will cancel 2, then 1 will remain, so the overall units will be centimeters per second. So since you won't be using calculators, then you can leave your answer as a fraction like this: 1 over 25 pi centimeters per second. Okay, let's move. You have to be very fast in solving these problems because we don't have all day. All right, so what is the linearization Lx of the function f of x equal to 3x cubed minus x squared plus 3 at a equal to minus 2? I would like to believe that you recall the formula that you were taught in class, that the linearization of a function is equal to what? You evaluate the function at the given point A, and then to it you add the f prime at A, then x minus A. This is straight away derived from the equation y minus y1 equal to m into x minus a minus x1. So if you have a function like this and we have a curve at this point A, if we want to find the linearization at that point, if we want to find the equation of this straight line, which is a tangent at that point, what we do is if this curve is called f, so we will need, so the gradient of the tangent mt is equal to f prime evaluated at A. Okay, and the coordinates of this point are A, the x coordinate, and the y value at this point is the evaluation of the function there. So with these 2 points, if I have the gradient and the point in question, I can use this formula to find this. So then the equation of this straight line, which is the tangent, will be y minus, and the y1 there is f of A equal to m is the gradient of that line, which is just equal to f prime A into x minus the x1 is the x coordinate, which is A. So you move this f of A to the right hand side and you end up with f of A plus f prime A into x minus A, which is exactly the same equation for the linearization of a curve, which is exactly that. So it's not that special and it's not that difficult to comprehend. So it's very easy to derive. So, but you were not asked, just that I wanted you to have a feel of what's going on. So let's come back to the question. So as you can see in this formula, we will require f of A, we will require f prime. So let's calculate these things separately. Let's start off by calculating f prime of x. The derivative of f of x there will be 3x squared minus 2x. Okay, the derivative of 3 is 0. Now let's evaluate this derivative at the given point. The given point is negative 2. So if you do that, it will be 3 into negative 2 squared minus 2 out, negative 2 in there. If you simplify, this is a 4 times 3, that's 12. 12 plus 4, which is 16. Okay, you just need to be very, very careful there. Then we will need an evaluation of the function at the given point. So let's calculate f of evaluated at minus 2. So we have minus 2 cubed minus then minus 2 squared plus a 3. If you simplify fully, this is negative 8, then minus 4 plus 3. This is minus 12 plus 3, which is negative 9. So I think we have everything now, so we can calculate the linearization. L of x is equal to f of A, which is our f of minus 2 is negative 9, plus f prime evaluated at negative 2 is 16 into x minus 2. Okay, so simplifying this way, that gives you minus 9 plus 16x plus 32. Therefore, the linearization which we are required to find is 16x plus 23. Okay, this was not so difficult. Let's move on to the next. I think it's a word problem. Yep. Okay, so we are given a scenario here. A ladder which is 10 meters long is leaning against a vertical wall. The bottom of the ladder is sliding away from the wall at a rate of 2 meters per second. At what rate is the top of the ladder sliding down the wall when the bottom of the ladder is 6 meters from the wall? Clearly define all variables and include a sketch. Okay, so probably the situation is like this. We have a ladder that is leaning against a vertical wall. Okay, this is exactly what we are told. So there's 90 degrees there, and let's say the foot of the ladder is x. Okay, what units are we using? Meters. And then let's say the vertical height of the way the ladder is touching, let's just call it y. Let's be consistent. Y there. Okay, so if the ladder is sliding away like that, you can see that x will be increasing, so dx dt will be positive, but y will be decreasing. The y values will be decreasing, so dy dt will be negative because it's being reduced in value. So let's write down so let y be the point of contact of the ladder and the wall. Okay, and then also let x be the distance of the foot of the ladder away from the base of the wall. They said we must define these parameters, okay? And let the length of the ladder be L. Okay, so we can just have a letter L there. All right, but we are given some data. We are given some data that the bottom of the ladder is sliding away at a rate of that. So dx dt is equal to. So since it's sliding away, so x is increasing. So if it's increasing, then it's a positive 2 meters per second. Now dy dt is unknown, right? We don't know. Actually, the question wants us to find dy dt, but obviously it must be negative because the size of y is decreasing with time. Okay? So so they are saying now we should answer the question at the instant when the top of the ladder is 6 meters, when the bottom of the ladder, when x is equal to 6. Okay, we should also try to determine what will be the at the instant when x is equal to 6, what is y, but L is always known to be 10. Okay, L will never change. Okay, so let's write down, so using Pythagoras, let's write down the differential equation. Using Pythagoras theorem, we can clearly see that L squared is equal to x squared plus y squared. There's no doubt about it because we have a right angle triangle there. So carrying out implicit differentiation, you have 2L dl over dt being equal to 2x dx over dt, because every variable is changing, is depending on time, is changing with respect to time. So we do implicit differentiation. Soon after differentiating it, we plug a derivative. Okay, plus 2y dy over dt. Okay, so now there's something that is quite interesting here, because will L change at any given time? Will the ladder expand or contract, the length of the ladder? The answer is no. The ladder's length will not change. So the L dt is always 0. It will remain constant. So L is constant. So the L dt is always 0. So then the equation now becomes 0 equal to 2x dx over dt plus 2y dy over dt. Remember, the question wants us to find dy dt, so we just have to make dy dt subject. So therefore, dy over dt is equal to x, so it's going to be negative, right? dx divided by dt, dx dt all over y. Okay, so as you can see, before we evaluate these things, we know dx dt, we know x at the instant in question, but we don't know y. So we use this set of data that we're given to calculate the value of y. Remember, this is a right angle triangle. We know 10 here, we know we have a 6, but we don't know y. So using Pythagoras, we have 10 squared equal to 6 squared plus y squared, and y squared is equal to 100 minus 36. Okay, and y equal to square root of 64, which is equal to 8. We only take the positive root because length is not the magnitude of length is not negative. Okay, the size of the length of something is never negative. Okay, so we only take the 8. So we now have the set of data that we want. So therefore, the dy over dt that is asked, the rate of decrease of the height y is negative. X, we know that x is going to be a 6. Dx dt is going to be 2. So this will be, if you look at the units, x is in meters times dx dt is in meters per second all over y is 8 meters. So meters and meters will cancel. 2 into 8, 4, and then 2, that's minus 3 over 2. Okay, so this will give us minus 3 over 2 meters per second. So the rate at which the height is changing is minus 3 over 2. You just have to answer the question appropriately right at the bottom. Okay, let's move on to the next. I think I have one more question left after this problem 2. A hot air balloon is rising vertically at a rate of 5 meters per second. A cyclist is riding along a straight road at 10 meters per second directly towards the point on the ground below the balloon. At what rate is the distance between the balloon and the cyclist changing when the balloon is 50 meters above the ground and the cyclist is 30 meters from the point beneath the balloon? Clearly define all variables and include a sketch. Okay, so let's say this is our balloon. Okay, so it's going up, but we have someone on the ground there who is cycling in this sense. So the man is right here. We can't draw the bicycle, right? We can't draw the man on the bicycle. We just put a dot, and so let's name this. So we know that it's directly below. So we know we have a 90 degree there. A hot air balloon is rising vertically at a rate of. So so we will say let y be the vertical height of the balloon. Okay, and let x be the distance the cyclist is away from the bottom of the from directly, it should be directly below, directly what? Directly below the directly below the balloon. Okay, the wording should be good. Okay, let y be the vertical height of the balloon. Let x be the distance the cyclist is away from directly below the balloon. And what else? Let s be the separation of the cyclist and the balloon. We are defining variables, so we are saying this distance between these two guys is s. Okay, so let's try to see the data that we are given. We are told that dy by dt, the rate at which this balloon is rising, is equal to 5 meters per second. It's positive because y is increasing with time. Okay, and also we are told that the rate at which the cyclist is riding towards the bottom of the balloon, below the balloon, is dx over dt. But I'm sure if this guy is going like this, you can agree with me that x is reducing in size, so dx dt has to be negative 10 meters. This is very important, guys. This is very, very important. Whenever we are shrinking the distance, we apply a negative. When we are increasing the distance, we put a positive to the derivative quantity, to the differentiation, all right? Dx dt is equal to negative 10 in this case, because the distance x is shrinking, it's being reduced. Okay? And what else are we given? At the instant, we are asked to find at the instant when y is equal to, when the balloon is 50 meters, at the same time when the cyclist is 30 meters away. The question is asking us to find at what rate is the distance between the balloon, and so the question wants us to find the SDT. Okay, the question is saying find the SDT. So again, using Pythagoras, we can see that s squared is equal to x squared plus y squared, and then carrying out implicit differentiation, you have 2s ds by dt equal to 2x dx dt plus 2y dy dt. Now we want the s dt to be subject, divide everywhere by 2s, so therefore the s dt is equal to x dx dt plus y dy dt all over s. Okay, this is straightforward. So before we simplify stuff, do we know x? Yes, we know at that instant. Dx dt we know, y we know, dy dt we know as well. So we can immediately simplify stuff. So it's going to be 30 for x there, and dx dt is minus 10, and plus y is 50 into dy dt is 5 all over s. Now we don't know s. Let's calculate s, guys, at this instant. So if we have a triangle like this, we know y is 50, x is 30, so this is s. So s squared is equal to 50 squared plus 30 squared. So s is equal to square root of 2500 plus 900. Okay, is this okay? 9, yeah, I think that's it. Then square root of that, this should be square root of 3400. Okay, so this is square root of 3400 here. So let's simplify further. This is equal to minus 300 plus 250. So we have minus 50 over root of 3400 is the same as root 34 by root of 100. Okay, of course these are meters per second, right? So this is equal to, this is 100, so this 10 will cancel with that, and then I'll have minus 5 over square root of 34 meters per second. Okay, this is not a 5, guys. This is an s for seconds. Okay, so this is the answer. ds dt is that. All right, I'm pretty sure that you are following. This one was a bit tricky, but let's see if we'll be able to do it. It's not so difficult. If you follow me, then you understand. Two airplanes are flying at different altitudes. Plane A is flying east at 400 kilometers per hour at an altitude of 3 kilometers, while plane B is flying north at 300 kilometers per hour at an altitude of 4 kilometers. At what rate is the distance between the two planes changing when plane A is 5 kilometers east of a reference point and B is 2 kilometers north of the same point? Clearly define all variables and include a sketch in your answer. So I'd like to draw a funny sketch, but I don't know if you guys will be able to follow me, but let's see. This is the north direction, and you can agree with me that this is south, this is east, this is west. Okay, now let's read through the question so that we can try to feed in information. Two planes are flying at a different altitude. Plane A is flying east at 400 kilometers. So plane A is somewhere here. Let's call this point A. This is plane A, and this plane, let's say this is the ground. Okay, let's say this is the ground. So plane A is flying east at 400 kilometers at an altitude of 3 kilometers. Okay, this height. All right, while plane B is flying north at 300 kilometers at an altitude of 4 kilometers. So this line, the east, or if I'm going to draw, plane B is, this is 3, so it should be 1 kilometer above. Okay, so if I want, I can draw I can say this is the position of B, where this height alone is 1 kilometer. Remember, this is plane B is 4 kilometers in altitude, so I should have 3. Remember this. Okay, there. Otherwise, someone will fight with me. So this difference is just 1 kilometer, right? But if I'm going to continue this dotted line to the ground, this should be 4 kilometers. Okay, the entire thing from the ground. Okay, and now if we go back to the question, let's read again. At what rate is the distance between the two planes changing? So the actual effective distance between these two planes is this. Let me try to draw a straight line. Okay, that bold line, let's call it D. Okay, at what rate is this distance between the two planes changing when plane A is 5 kilometers from a reference point? So let's take this point as reference. So we know, let's call this x. Okay, from the x distance, the distance from the reference point, the point O, let's call it x, and all the vertical distances we call them y. All the distance along the northern point, we call them y. All these points, so y is along the north line, south north line, and x is the distance along the west east line. Okay, and point O is kind of the reference point. All right, so what's happening here? So I want you to see that. Okay, so we will name these. Let me put it another dotted line here. I'll explain this line. So there are two things that are intertwined here. So let's define these our variables first. Okay. So let x be the distance, the horizontal distance, or the horizontal distance of A from the reference point. Okay, let's define y again. Let y be the, again, horizontal, this is key, horizontal distance of B from the from the reference point. Okay, so you can clearly see that the horizontal distance of B from, we know that the vertical distance is just 1 kilometer, all right? We know that it's only 1 kilometer from this north line. Okay, so, and you can appreciate, guys, that this is a 90 degrees, and again there is a 90 here. Okay, so let me call this dotted line S. You can see that we have a triangle. I will just draw the triangle in red so that you can see it clearly. This, that, and that. So I'll just draw it here. So we have an S there, 90 degree here. This is Y and this is X. So you can agree with me that S is the hypotenuse. So S squared is equal to X squared plus Y squared. Okay? But we are not concerned about S. We are concerned about D, because D is the distance between these two planes. All right? So then let's come up with an equation for D. Look at this triangle. Let me take a different color, the blue one this time. If I draw this triangle, please follow my blue pen now. Perfect. If you look at that blue triangle, you agree with me that this is S, this is D, and there's a 1 there. This is 90 degrees. You can see that D squared is equal to S squared plus 1. This is the master differential. This is master equation from which we will get our differential equation involving D. All right. So from this equation in blue, you agree that D squared is equal to, and S squared is just right here, x squared plus Y squared plus a 1. Okay. And if you are going to do implicit differentiation, you are going to have 2D times d by dt equal to 2x dx dt plus 2y dy over dt alone, because derivative of 1 is a 0. So the question wants us to find the rate of change of the distance between the two planes. So we make d by dt subject. So we end up with x dx over dt plus y dy over dt all over d. The 2's will cancel. So if we don't have all the information, let's try to list down what we are given. We are told that the speed of the aeroplane A is 400 kilometers per hour, and we are told that the speed of the car B is 300 kilometers per hour, and we are asked to calculate dd by dt at the instant when x is equal to 3, right? According to that, it was 5. It's 5. Sorry, not 3, 5. If you go back to the question, it says 5. Okay? At what rate is the distance between the two planes changing when plane A is 5 kilometers east of the reference point and plane B is 2 kilometers north? Okay? So, at the instant when x is equal to 5 kilometers, okay, draw, okay, let me take that. 5 kilometers and y equal to 2 kilometers. Okay, but do we know d at that point? We will have to calculate d, otherwise we will get stuck. D is required in our formula. So, but if you look at this triangle, it requires, so we know that, you look at this equation here, this one where I'm putting a star. So you can see that d is equal to the square root of x squared is 25. We're using this information here, plus y squared is a 4 plus 1 according to that formula. So d is equal to root of 30. So let's take all this information and feed it into that formula. So dt by dt, the one we are required to find is x is 5 and dx dt is 400 plus y is 2 and dy dt is 300 all over root of 30. And the units are meters per second because distance is just kilometers per, kilometers per hour. Using the units should match. Okay, so this is equal to, just a matter of simplifying now. So if you say 5 times 420 with 2 zeros plus 600, you end up with 2600 over a root of 30 kilometers. If you don't have a calculator, you can leave your answer like this, or if you have calculators, I think this should be to 2 decimal places. It should be 474.34 kilometers per hour. Okay, so that's it, guys. I'm sure if you missed something, if you play back the video, you'll be able to catch up. I hope that you understand these problems and they'll help you to prepare for the upcoming assessment. Thank you and enjoy the rest of your day. Bye for now.